Okay, so we just got done talking about sort of the general concept of present value and future value and how we can relate cash flows in the future to the present by discounting at a certain rate, and we can relate cash flows from the present into the future by compounding or growing at a certain rate. I don't like the way that your textbook uses interest all the time as if that were the only way that money grows, because it's not, as we know. So we'll just say it's growth rate, okay? So for both of those, right, if we have the rate of growth, the number of time periods that your investment is growing, and the original investment, we can solve for the future value. Okay, and likewise, if we have a future value, and we know the discount rate, and we know the number of time periods that it's being discounted back to the present, we can solve for the present value. And so this section over here in your book is titled, one equation and four variables. Okay. Now, you can do all of these formulas by hand if you want, but guess what? Excel will do it for you. Okay, so when I show you how to set up the quantitative homework, right, I'm going to have you use Excel's functions for all of these questions that are asked. The hard thing in this chapter is not the mechanics of setting up the functions. The hard thing is getting your head around what's being asked for. Is it a present value? Is it a future value? Which one's which? And then there's other things in the homework where they're using financial terminology that you may or may not be familiar with. So when you invoke an Excel time value of money function, okay, the first thing that you are going to be prompted for is the rate. Okay? And the rate is either the interest rate or the discount rate. And the thing to keep in mind when you're doing this is that it has to be given for the correct time increment. Usually, interest rates are quoted on an annual basis, but if you're looking for a monthly result, you have to divide the interest rate. Like, let's say you have a 6% interest rate annually, and you're looking for how much your value is going to be in 2 months. You have to divide up your interest rate by 12 to get a monthly rate. Likewise, your number of periods is the next argument that Excel is going to ask for, and that's the number of periods over which you are moving the value, either bringing it forward or backward in time. So again, usually we think of this in years, at least the way that we've been describing these concepts. But if, like my previous example, if the rate was 6% a year, and you want to know how much your investment is going to be worth in 2 months, you got to divide up that 6 by 12 to give you 0.5% per month, and then multiply it by use the 2 months in the argument. Okay. Now the next function that the next argument that Excel has in its time value of money functions is this payment argument, which we are not going to be dealing with here in chapter 3. You just use a 0 for that in those functions. And then the next argument that you might see is the future value. And then this question of type is, again, you just leave it at 0 for now. We might come across this in later chapters in this book. at some point I'll discuss what that means, but it's not relevant for our discussion right now. And then the last argument that you might see is the present value, which of course just refers to the present value in the function. Okay, so these are Excel's arguments here. Now, the next thing I want to go through a little bit is this portion with the applications. Okay, so like I said, this book doesn't have a lot of content in it. It just explains some concepts, just introduces some concepts, and then these concepts have no meaning without examples, right? So they give you these neat little examples, and one thing that I want to note is that they use a timeline to help you to get your head around this, and I strongly recommend doing that. And when we get sort of more into these examples, I'm gonna be pretty diligent about encouraging you to do that, particularly in the next chapter and beyond. So we have a retirement goal here of $2 million, and you've got a 6% growth rate that you can apply over 40 years. And so the question is, how much do you need to invest right now to have $2 million 40 years from now? And the answer, believe it or not, is only like 200,000, 194,000. Now, the book shows you 3 different ways of doing this. One is to actually solve it out using algebra. Another is to use a financial calculator. So you can get a financial calculator app on your phones. It works pretty well. And I'll be happy to show you how to do that when it's convenient. But my preferred way of working, obviously, is using a spreadsheet. And I want to note that in these examples, right, first of all, they give you the same result. So you solve out the present value. This would be the formula that they used. And we'll be doing that a lot in the examples for the homework. So, there's these neat little videos in the book that you can go ahead and watch if you want to. But I want to go down to the last example in this application section, because everybody loves a sports agent, right? So here's our little setup here. This is a cool example, right? The sports agent has 3 different $7 million offers for his client. Right. So I went and copied all this information over here into my spreadsheet so that I could show you that these are all $7 million contract offers. Right? Each of them have a value of $7 million in the total sum of all of these 7 cash flows. So they include a signing bonus as well as 6 years of payment, and they add up to $7,000. The question is, how do you decide among them? And this really gets to the heart of this chapter's material. Now, how you decide among them, right, is you bring each of these cash flows back to the present value. And so they show you over here in the book, right? So the Northwest contract, right? We get $1 million now, $1 million a year from now, which we discount by 1 iteration of that 6%. So the value is 943. Year 2, we have another $1 million cash flow, which in today's dollars is worth 889, etc. And you add all those up, right? And you get to the sum of all of these present values is 5.9 million. So the 7-year contract for the Northwest team, even though it's $7 million overall, in its present value, it is 5.9 million. And if you do that over and over again, right, with each of these 3 different contracts, going through that same procedure, you get different values for the present value, right? Now, Excel, needless to say, has an app for that, has a function for that. And so let me show you. It's called the net present value function, and we'll get a lot more into that the next module. Okay, this is where I live, people. Net present value. But what you see is that these different $7 million contracts, let me make those red so you can really, they stand out. So these different $7 million contracts all have a different present value, because what you can see here in the Midwest team, right, it's back weighted. The biggest cash flows are occurring towards the end. And so that's only giving you a present value of 5.5, whereas the East Coast team is front weighted with the bonus, but then back weighted with the rest of the cash flows. So that gives you 5.8. And then this one in the Northwest gives you the highest present value. It's all about the timing of the cash flows. And so that's where I'm going to leave this video. Okay, and the only way you're going to learn this stuff really is to just do it. So I'll show you how to do some of the practice problems, not all of them. And then I'll just let you practice. Okay.